Here is a matching type question. Study the items in both columns carefully. Try to work out the matching before we solve it together. Let us begin solving this step by step. To solve this problem, we apply the principles of electrophilic aromatic substitution, EAS electron-donating groups, EDG, activate the ring and direct ortho-para, electron-withdrawing groups, EWG, deactivate the ring and direct meta. The more activated ring is preferentially attacked. Compound 1, PHC, is equal to O, CH2PH, deoxybenzone. Ring A is directly attached to the carbonyl, C is equal to O, which is a strong EWG via resonance and induction. Ring A is deactivated, meta-director. Ring B is attached via CH2, which insulates it from the carbonyl. Ring B behaves essentially as a plain benzene ring, mildly activated relative to A. Therefore, ring B is more reactive and substitution goes ortho-para. Answer B. Ortho-para. Compound 2, AN, CH3, so 2B, N-methyl sulfonamide. Ring B is directly attached to SO2, a strong EWG. Ring B is strongly deactivated. Ring A is attached to the nitrogen of the sulfonamide. The nitrogen lone pair, although partially withdrawn by SO2, still donates electron density into ring A via resonance, N is EDG toward ring A. Ring A is more activated. Therefore, ring A is preferentially attacked, ortho-para direction. Answer A. Ortho-para. Compound 3, AC, is equal to O-OB, phenyl benzoate. Ring A is attached to the carbonyl carbon of the ester, acyl side. The C is equal to O is EWG, deactivating ring A. Ring B is attached to the oxygen of the ester, phenoxy side. Oxygen donates electrons into ring B via resonance, lone pair on O into ring, activating ring B as an EDG, ortho-para director. Despite the partial withdrawal by the carbonyl, the net effect on ring B through oxygen is activation relative to ring A. Therefore, ring B is preferentially attacked, ortho-para. Answer B. Ortho-para. Compound 4, benzodiazepinadiene with ring A and ring B both fused to the lactam ring. Both ring A and ring B are fused to a 7-membered ring containing 2 amide, lactam, carbonyls and 2 N-methyl groups. Each ring is flanked by an amide nitrogen, EDG, donates into ring, and an amide carbonyl, EWG, withdraws from ring. The two effects partially cancel. Due to the symmetry of the molecule, both rings experience similar electronic environments and the competing EDG-EWG effects. All positions on both rings are approximately equally reactive. Ring A is attacked preferentially or equivalently, but importantly the net activation from the nitrogen lone pairs means both rings react at all positions. The answer given is ring A, all positions. Answer A, all sites. Compound 5, AC, is equal to O, CH2N, CH3, C, is equal to O, B. Ring A is attached to a ketone carbonyl, which is EWG. Ring A is deactivated. Ring B is attached to an amide carbonyl C, is equal to O, N. The amide nitrogen donates into the carbonyl, but the carbonyl still withdraws from ring B. However, relative to ring A, plain aryl ketone, strong deactivation, ring B attached to an amide C is equal to O is also deactivated. The amide carbonyl is EWG toward ring B, meta-director, but we must compare both rings. Actually, ring B is directly bonded to the amide carbonyl carbon. In amides, C is equal to O is still EWG toward the attached ring. Ring B is meta-directed. Ring A, aryl ketone, is also meta-directed but more strongly deactivated. Comparing, The amide C is equal to O attached to ring B is less deactivating than the ketone C is equal to O attached to ring A. Amide resonance reduces electrophilicity of carbonyl, making it somewhat less EWG toward the ring. So ring B is relatively more reactive than ring A. Ring B is attacked preferentially. Meta orientation. Answer B. Meta. Compound 6. Fluorine indinone type fused system with ring A and ring B connected through a 5-membered ring bearing C, CH3, 2 and C is equal to O. Ring A is fused to the 5-membered ring containing the C is equal to O, ketone. The carbonyl is EWG toward ring A. Ring B is fused to the 5-membered ring on the C, CH3, 2 side, no carbonyl directly on ring B side. The gemdimethyl quaternary carbon is slightly EDG. Alkyl groups are weakly electron donating. Ring B experiences no direct EWG effect. Ring B is more electron-rich and thus more reactive toward electrophiles, with ortho-para direction relative to the ring junction. Answer B. Ortho-para. Therefore, the correct answer is 1. Reactivity B. Substitution ortho-para. 2. Reactivity A. Substitution ortho-para. 3. Reactivity B. Substitution ortho-para. 4. Reactivity A. Substitution all position. 5. Reactivity B. Substitution meta. 6. Reactivity B. Substitution ortho-para. Therefore, the correct matching is 1 matches, reactivity B. Substitution ortho-para. 2 matches, reactivity A. Substitution ortho-para. 3 matches, reactivity B. Substitution ortho-para. 4 matches, reactivity A. Substitution all position. 5 matches, reactivity B. Substitution meta. 6 matches, reactivity B. Substitution ortho-para.